Okay, so it's this is a recap on Friday's lesson on week 11, Friday. So, just regarding the examples that we go through, if you could just use the page number, which you can barely make out here, but it's down the bottom right corner, and left and right, because I don't label the questions themselves during the class. There's a test on Monday, which I'm going to go. This is mainly what this is about. I'm going to go through the questions for your test. And then the lesson itself was about equivalent. You know, these are the for the overall learning unit. We only might have done a few of these, or they would be blended in. But you need to understand what equivalent expressions are, equivalent fractions, to add fractions with common and different denominators. Work with multivariate expressions. We're actually doing this. Okay, we were doing this working with adding expressions together. That's what we're doing today. Add, subtract, and simplify linear expressions. We were doing this today on Friday. We haven't done that yet. Divide a quadratic by a linear term. It's very easy. And then find integer solutions to linear equations. I threw one or two of them in. It's really a continuation on from writing these as single fractions. Now this is your test, and I think this is what we want to focus on. I might cut this video short and just work on the questions in the test. Okay, so I'm just going to do them in a very traditional manner. I know you all love your 4 pens, but I'd much prefer you to have actually 4 pens and keep the room quiet while we're working. And a pencil. Always have a eraser, and always have your topper, your pointer we call it, because point is an important word in maths. So your pointer, your eraser, your pencil, and your pens of different colours. Okay, but we can get away without having the different colours. Black is fine, black or blue. Okay, so I'll keep the so first question is to solve 4x plus, okay, let's go. Click on a light here, might be better. Right. So to solve, my cup of tea. Now 4x plus 5 and 6x minus 7 are two binomial factors getting multiplied together to equals 0. So this is already factorized and you have to solve it. So we'll use what do we use? We'll use the zero product. It's a product that gives us 0. So we'll use the zero product rule. To get us two equations. 4x plus 5 equals 0. X equals minus 5 over 4. I'll do a further step on the next one. 6x minus 7 equals 0. That's that one equals 0. That implies that 6x equals 7. That implies that x equals 7 over 6. Okay, so I'm finished. And because I've kind of left the two answers get separated from each other, I'll write the answer as x is an element of the solution set. Put the positive one first. Well, actually I should have probably put the negative one. Well, I'll tell you what I'm thinking here. Yeah, the negative. It doesn't matter. It doesn't have to be in order. Could have put it in order so that on the number line this would appear first and that would appear second. Okay. Oops, went off screen. I want to avoid that kind of thing happening next time round. So the next question. X squared minus 7x equals 0. Okay. Now, we have to solve this algebraically. We can think of it in terms of a diagram, but let's think of it algebraically. And x is common to both. In expanded form, this looks like this. Okay, and you can clearly see there's a common x. So taking out that common x, I'm left with x take 7 equals 0. Applying the zero product rule, I get x equals 0 and x minus 7 equals 0. Well, x is still equal to 0 and x equals 7. And that's question 2 done. Question 3. 14x squared. Obviously the numbers won't be the exact same, but there'll be nothing else different between this and your test. I'm asking you to develop your skills, and I'm not asking you to develop your problem solving yet. Okay, so what have we in common? Well, this is 2 times 7 times x minus 3 times 7 times x equals 0. And it's quite okay, and it may be a very good move for you to expand like this. Now we're looking for commonality. What's common? Well, there's an x here and there's an x here, but also there's a 7 here and there's a 7 here. Now let's take that 7 out, 7 and the x out, leaving 2x unmarked there, and minus 3. Okay, now at this point, and there's a bracket there, at this point you can divide across by 7, because dividing 0 by 7 is not a problem, whereas dividing 0 by 0 is a problem, and x could always be 0, and it is 0 in this case. So you can't divide by x ever. You can divide by 7. So we can simplify this to x times 2x minus 3 equals 0. That's your next move. Then we go ahead and factorize this. X equal to 0, 2x minus 3 equals 0, 2x equals 3, x equals 3 over 2, and we give the answer 0, 3 over 2. Okay. Next we have 2x squared plus 6x equals 0. That's 2 times x plus 2 times 3 times x equals 0. Now you don't have to do this step. I'd like most of you to say take out the 2x from here, but if you're having problems with the fact that 6 is a product of primes, and if you're having a problem with seeing the prime factorization of 6, or seeing what a power means, a square means, then just by all means write it in terms of a sum of multiple products, extended products. Okay, let's search for things that are common. There's a 2 common and an x common. So take them out. 2x. Leaving x, 2x comes out, x plus 3 equals 0. X by x plus 3 equals 0. And I'm just going to begin to take it that you're able to take it from there, and we'll just get that x is an element, and you can do it the other way as well. X is an element of 0, negative 3. Okay. The next question, your homework, or for your test, is question 5. X squared plus 8x plus 7. Now, representing 7 looks like this. Okay, I'm trying to get two numbers to multiply to 7, and it adds to 8. But 7 is a prime number, so I'm not going to be able to rearrange those dots in any other way. And indeed, 7 and 1 is 8. Okay? So when you see primes, you're looking for a very, very specific, you have only one possibility here, 8. Unless this is minus, and then you'll be looking for a 6 here. Okay, so just to be very clear, 7 by 1 is 7, and 7 plus 1 is 8, is what we're looking for. It means we have our numbers 7 and 1. Now, it's an x plus and an x plus, because that's the pattern, that's the form of our answer for an expanded x squared plus 8x plus 7. So the big number goes first out of good habit, though not absolutely necessary here, and the next number goes there, equals 0. So you get x plus 7, x plus 1, in turn, both of them being equal to 0, and you get x equals minus 7, x equals minus 1. Okay, we're on to question 6. X squared plus 14x plus 33. Now 33 is a semi-prime. This number is not 34, so we're going to have to split this. Let's try 13 and 3. Now you'd normally say let's try 3 and 13, but I want to put the big one first. Okay, out of good habit. Oh, that's not working out for me, but that's supposed to be 11 and 3. Okay, 11 and 3 is 14, so it's working out perfectly. You can just point that out. 11 plus 3 equals 14, and 3 11s equals 33. Forgive the writing, it's a bit messy. Okay, here we go. So we're going to go into an x plus and an x plus. And remember what I was saying in class, get that done before the so-called number post person arrives with the 11 and the 3. Where should I put the 11? Well, it doesn't really matter, but put it there, please. Where should I put the 3? It doesn't really matter, let's put it there, please. So try to disconnect or break it into 2 steps, the form and the population with the numbers, or the delivery of the numbers into that form. Okay, x plus 11 equals 0, x plus 3 equals 0 is what the zero product rule tells us. X equals minus 11, x equals minus 3. Okay, the next question is x squared minus 19x plus 70. Equals 0. Now put 70 into the calculator, but note that it's 10 times 7. Okay, 7 by 10, but 10 is still not separated out, so that's 2, 5 and 7. And you probably do not need to think analytically like this, but with 2, 5 and 7 on an association triangle, we're trying to get 19 in the middle. Well, the 14 and the 5 will work out perfectly, and the reason we want plus to get 19 is that this is a plus. So in other words, the form of our answer is an x minus. Okay, and the 2 minuses add and keep their sign to give negative 19. So because this, so that's the way it works. When this is a plus, you know you're adding. Now we have 14. Remember, the big one goes here, even though in this case it doesn't really matter. The small one goes here, equals 0. Use the zero product rule to make 2 formulas, 2 equations, each equal to 0. Two equations. I could come up with some fancy big word now, and I'm probably better off not to. So equations can be equal to 0, or they can be something on the right, left, and something on the right. Okay, so x equals 14, or x equals 5, or use the set terminology down at the bottom. Sketch there would look like this. 70 here, 5 here, 14 here. Okay, the next question is x squared minus 10x plus 21 equals 0. So regarding whether it's equal to 0 or not, when it's equal to 0, sometimes you call the roots the zeros, but you only call them the zeros if it's being equal to 0. So if you would say, there's your x and y axis, if you were saying, hey, where is this quadratic equal to 5, you wouldn't be getting zeros, you'd be getting the roots of the equation. If you had blah 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 equals 5, you'd be getting the roots of the equation, not the zeros. So in other words, if the roots happen to be of the equation, if the equation happens to be equals 0, then the roots are also called zeros. Okay, so let's go. We have to split 21 into 2 numbers that add to 10. Well, that's simple because this is a semi-prime, this is a 2 prime, and that's 7 and 3. And just to be pointing out, the only other thing this could have been is 22, and it isn't 22. Okay, so we have the numbers 7 and 3, and the form is x minus. In goes postman comes, in goes 7, in goes 3. Okay, and I just x minus 7 equals 0, x minus 3 equals 0, x equals 7, x equals 3, box it. And we push on. So, sup of tea, after the tea, and up Here we go. Okay. Oh, we have a minus. Now we want to watch ourselves at this one. Okay, so what's that minus mean? We have a plus minus. The only way we're going to end up with a minus is that one of these is plus and one of these is minus. Now I could just say throw down the plus and the minus any old place at all. We'll just say to you, it's there's a battle going on between plus and minus, between two numbers that we're going to establish, and the plus wins, and you're going to put that sign there, and you're going to put the other sign here. Okay, so the next question on will be similar. Plus for there, and then minus, not because of that, but because we know there's a plus and a minus. The next one on again is a minus minus and another minus minus. Do you like the copy? Because you're using this copy, because what I want you to do is working question per page or question per half page. No harm in using a question per page. 88 questions, €2. That's good value.